Alright, so we're going to go over the ambiguous case of law of signs. So we have the ambiguous case whenever we try to sketch our triangle and the information that's given to us describes angle side side or side side angle. So as an example, the reason this is ambiguous is because if I sketch a triangle, I know angle y, I know side y, which would be opposite angle y, and I know side z, which would be opposite angle z, which means we have the side-side angle case, or if you read it backwards, angle side-side. So that's a way to remember it. So this is what we're going to need to do when we're trying to solve this kind of triangle. The scale drawing is going to be really helpful. I'm going to make a list of steps. First thing we need to do, we have two sides. So it's really important that we set a scale and we identify which side is which. So we first need to determine three things. You need to know which side is the opposite side, which side is the adjacent side, and then you need to pick a scale that works for both of those sides. So I have angle y, which means side y will be the opposite side, which means that side z will be the adjacent side. Now to make this easy to graph or to sketch on my paper, I'm going to determine a scale that works for both. I'm going to use centimeters because it tends to be a little easier. I'm going to say 1 centimeter is 4 units. 4 works because I can divide 20 and 24. It won't always work out that nicely, but whenever you can, it will make it easier. So that means my y is going to be 5 centimeters, and my z is going to be 6 centimeters. Next, we're going to try to draw our triangle. Now, this is not the only way you can do it, but I think this is the easiest way, and it helps to be consistent. So whatever you do, you always want to be consistent so you don't confuse yourself. We are first going to draw a horizontal line, and that's going to represent the side of the triangle that we don't know, so this base here. So we're going to draw a horizontal line, and then I'm going to measure and sketch my lone angle. So I'm going to make a pretty good sized line down here. Let's go about halfway down the page. I want to make sure I have enough room. These take a lot of paper. Don't try to conserve too much paper on these. You don't want to make it harder just because you tried to cram too much in a small area. That's probably a longer line than I need, but we'll make it work. Somewhere on that line, I need to make a point. I'm going to call that y. And now at y, I'm going to use my protractor, and I'm going to measure my 50-degree angle. So make sure you line the 0 up with your horizontal line, count up to 50, and that little mark and this point are going to let me draw a straight line for one side of my triangle. Now, we're going to be drawing our adjacent side here. So we are sketching the adjacent side. It's important that we do it to scale so that we get the full picture. So I'm going to take a ruler. I decided that z earlier, I decided would be 6 centimeters. So I'm going to line that up. And we'll be as accurate as we can be to sketch 6 centimeters for that side. This is side z. So we're going to say z equals 24. I'm just going to label it so we don't forget. Angle y is 50 degrees. We'll label that so we don't forget. Of course, if this is side z, then we know angle z has to be down here, which means this has to be whatever the third angle is. Since we're using y and z, I'm going to call this x. Now, this is an angle side-side case. And there's a reason why it's ambiguous, and we're about to see. We don't know this angle. We do, however, know the opposite side. So we're going to measure our opposite side, and we're going to sketch it. This is where we need to be careful. So we're going to sketch the opposite side, which we know needs to be 5 centimeters. Now, we can't just draw that anywhere. If I draw it here, I'm not going to end up with a triangle. So we need to adjust our ruler, and the measurement will dictate where this side needs to go. So that looks about right. I'm able to draw a 5 centimeter side length here. So that's where I could put z. So we say y equals 20. Now this is why we call this the ambiguous case. When all you have is the side-side angle case is one possibility. However, there could be a second possibility, and this time there is. If you swing your ruler a little bit further over, and you always want to look for this if you're dealing with this case of triangle, I could also sketch a side here, and that could also be 20. And so I have another potential candidate for where z could go. So this is where we need to be careful. When you're dealing with the ambiguous case, or the side-side angle case, the angle side-side case, you need, when you sketch the opposite side, there may be two triangles. And the only way to really, at this point, the only way we know that for sure is to measure and see if we can draw two triangles. Now, with that information, we've been asked to solve. Most of the time, you're going to be asked to solve these triangles. We're going to solve them both. Now, in order to solve them both, we're going to break this into two triangles. Now, this is just the way I like to name them, just so I can kind of keep things straight. But I'm going to call these, I'm not going to be too creative. We're going to call them triangle 1 and triangle 2. I'm going to call triangle 1 the bigger of the two triangles, so that's with my side y over here. And I'm going to call triangle 2 the small triangle, so that's if I put side y over here. Now, I'm going to sketch these again. I'm not going to make them to scale, but you could, and it might give you a better idea of what all your side lengths and your angles are if you want to do that. But triangle 1, that's the big triangle, so that's y. I'm going to call, since this is triangle 1, I'm going to call this x1, and I'm going to call this z1, which is going to mean, well, if that's 50 degrees, this is still 24, this is still 20. This side length is going to be side length x1. Same thing for triangle 2. Once again, not drawing to scale, but if you wanted to draw them to scale again, you could. That might make it easier for some of you. This is y. That's still 50 degrees. This is still 24, but this is 20. We moved it over a little bit further. This angle here is going to be different. I'm going to call this one x2, which means this will be z2, and this will be x2. So from here, there's only one more thing we really need to watch out for, and then I think you guys can handle it. We're going to solve both triangles. Now there's going to be a lot of information floating around, so to make this a little easier, I recommend making a table. I'll make a triangle 1 side for the big triangle, the triangle 2 side, we'll hold the small triangle. Let's list everything we know. So angle y is 50 degrees for both. And I know I'm being a little repetitive here, but make sure you're organized. It's important. We know side z is 24, and that's true for both. And we know side y is 20. That's true for both. Now, what we don't know, that's going to be angle x1, angle z1, and side x1. Sorry, I'll move up so you guys can see. And that would mean this side's going to be angle x2, angle z2, and side x2. Those are the things that we need to figure out. We're going to have to round a little bit. I'm going to round to the nearest hundredth, but it's always okay to be more accurate than that if you would like. We're going to solve both triangles. Some tricks that we can use to do that. Remember, you've got your law of sines. We're going to fall back on that a lot. Remember, angles in a triangle add up to 180. That's going to be helpful. And the most important thing is we need to remember that when we do inverse sine of a value, your calculator gives you the reference number. We'll talk about what that means in a minute. Now, the first thing I want to do when solving is we are going to solve for the missing base angle. And what I mean by that is the angle that's on the bottom that you don't know. So we know y. We started with y. We're going to solve for z. And we're going to use the law of sines to do that. So Remember your law of sines. I'm going to take what I know, which is y across from y, so that's sine of 50 degrees over 20 equals, now the side opposite my z, no matter which one I do, is 24. You can see that from the two triangles here. Now here's the tricky part. I don't know if I'm solving for z1 or z2 right now, because you set both of them up the same way. They have the same numbers in both triangles. So here is how I'm going to do this. We're going to use our calculator. So I'm going to skip through this process because I trust that you guys can all do that. But we know using the law of sines that we're going to end up finding z. So in my calculator, 24 sine of 50 divided by 20, and we need to take the inverse sine of that number, and we find z is approximately 66.82 degrees. My calculator is in degrees, so that's in degrees. So we have that angle. The question is it z1 or z2? There's two possibilities here, but the calculator only gives you the reference number. Remember, the reference number is the angle in the first quadrant when you think about your unit circle. 66.82 degrees is the reference number for whatever angle is in the second quadrant. This is, and your clue here, is this is an acute angle. It's less than 90, which means if you look at z1 and z2, it's got to be z1. So this is 66.82 degrees. So z1 is 66.82 degrees. If that's our reference number for whatever z2 is, then that means z2 will equal 180 degrees minus z1. So when you start this, if z1 is your acute angle, z2 will be 180 minus whatever z1 is. If z2 is your acute angle, vice versa will be true. So whatever angle you get, to get the other one, you need to subtract from 180. So that means, and it's easy enough to do, 180 minus that number, and we get that it's 113, roughly, 0.18 degrees. So z2 is about 113.18 degrees. Now, there's still a bit of work to do, but it's a little easier now. We know two angles, which means that we can find the third angle by subtracting from 180. So that's 180 minus 50 minus 66.82 to get x1. So that gives us 63.18 degrees. We'll do the same thing over here. 180 minus 50 minus 113.18 gives us 16.82 degrees. You'll notice some similarities. That's because they're all adding up to 180 on each side. Now, x1 and x2, we're going to have to do a bit of work, but we can use the law of sines for both of them. So sine of 50 degrees over 20 equals sine of 63.18 degrees over whatever x1 is. We'll solve for x1 that way. And then we'll do sine, once again, of 50 degrees over 20 using y over y equals sine of 16.82 degrees over x2. You'll notice the setup is exactly the same, but the angles are different, and that's just to represent which of the two triangles we're talking about. Use your law of sines and the ways that you solve proportions to answer that, and we'll find that x1 is approximately 23.30. You should get something very close to that. And x2 is approximately 7.55.